most of 5a is about percent increases and percent decreases. But first, there is some conversion stuff, since we do have to do that in order to do the computations. So just the idea of converting a percent into a fraction or maybe a decimal, and then if it's a fraction, maybe to reduce it, because if you can reduce it, you've got smaller numbers. Usually that makes the computation a little bit easier. So first of all, if you're going to convert a percent into a fraction, basically this first thing right here, like that concept, that's the idea, where you can think of a percent generally as the whole divided by the part multiplied by 100. So when you convert it into fraction form, basically then you're just trying to write it as whole over part, essentially. So what you can do is you can just divide the percentage, like whatever value you've got, by 100, and then from there, if that fraction reduces, so if the numerator and denominator have a common factor, then you can factor that out and you can reduce the fraction a little bit, which you can't always do. The example that's there, the 61% equals 61 over 100, 61 and 100 don't actually have any common factors, so that one you couldn't reduce. And then converting from a percent to a decimal, we're going to have to do a little bit of that too. That's not in this first initial part at all, and there aren't any specific questions where that's all you have to do in the homework, where it's just convert this percent into a decimal. They're always just convert this percent into a fraction. But it does help, because later, like when we're computing interest and things, then that is probably the thing that you want. So first things first, with these examples about how to convert percents to fractions. So the first thing is just write the number, like the numerical part of the percent, over 100. So like for 17%, you could just write that as 17 over 100. And now it's in fraction form, and 17 is a prime number, and 17 doesn't divide 100, so there's no common factor there other than 1, so that doesn't reduce any further. The other ones do. So the 86%, we can rewrite that as 86 over 100, but both of those are divisible by 2. Since 86 is 43 times 2, and 100 is 50 times 2, so that means that we could rewrite this as 43 over 50, and 43 and 50 don't have any common factors beyond that. So 43 is prime, there's not really anything else you can do. So if you want to think of this as that you're canceling out the 2's, I think that's what most people think of, and that's fine. I mean, that's going to be very effective to reducing fractions. Number 3, where it's 48%, so same starting point. We can write that as 48 over 100. We can go a little bigger than 2 as far as the common factor here. I mean, 2 will work, but so will 4. And that way we're going to do less steps. So 48 is 12 times 4, and then 100 is 25 times 4. So then we can write this as 12 over 25. And those 4's we can cancel out. Then the fourth one, 90%. All right, 90 over 100. Well, both of those numbers end in a 0, which means they're divisible by 10. So 90 is 9 times 10. 100's 10 times 10. So then this must be 9/10. Cancel out those 10's. Well, the 10 on the top with one of the 10's on the bottom, I guess. All right, so that's pretty much the idea for converting from a percent to a fraction. Now, the bulk of what this section is about is percent changes. So increases and decreases. And in both cases, the idea is that you have to take a portion of the original amount and then either you'd add or subtract it in relation to the original amount. So you're going to add if it's an increase, subtract if it's a decrease. So like it says there, starting up off the top, a percent increase, that involves adding a portion of the original amount to itself. So just to have kind of a basic example of how this works with no context or anything, if the original amount's 150 and there's a 4% increase, then what you do is you figure out what 4% of 150 is, and then you'd add that to 150. So like it says there, the new amount is equal to the original amount plus 4% of the original amount, plus because it's an increase, right? So increase is a plus, decrease is a minus. So the new amount, if you look at what I've got the original amount, the 150, and then plus the increase, right? So that right there in parentheses, that is the increase part. And so, okay, 4% of 150. I think this is easier to do with a decimal because most of these you end up putting them into your calculator anyway. You can do it with a fraction if you want to and say, well, 4% is 1 over 25, and then 150 divided by 25 is 6. That does work. Although I think most people are going to use the calculator here because they're not always that clean. So I think that ends up being, as a general strategy, probably more effective, is just to say, all right, when we've got to do this, just convert it into decimal form. And then if you can see it right away, like to do the multiplication manually, that's great. But sometimes you can't, and then you can just use the calculator. So I converted it into decimal form, and I just said 4% is going to be 0.04, right? Just move the decimal point 2 places to the left. So then I've got 0.04 times 150, which ends up being 6. So then we just have 150 plus 6. So the original amount, the 150 plus 6, which is the 4% increase, we get 156. The alternate way of doing it, which is faster, but I suppose is slightly less explicit, but if it makes sense to you, then certainly you can use it. You could say that the new amount would be 100% of what we start with, right? Which is just kind of a redundant way of saying the original amount. But 100% plus 4%, so 104% of the original amount. So what you could do to get 104% of 150 all in one shot, you could just multiply the 150 by 1.04. And you'll get the same thing. You get the 156. So that also works if you want to do it that way, rather than having the increase as a separate thing, or then you add it to the 150. If you want to do it all in one fell swoop, you could just multiply by 1.04. And the same thing happens with decreases. It's just that with decreases, you're subtracting. So you subtract part of the original amount from whatever the original amount was. So for example, what if the original amount's 200, there's an 8% decrease. So if it's a decrease, that means there's going to be a minus 8% of the original amount. So 200 minus 8% of 200, and we just have to figure out what 8% of 200 is. So again, I kind of did a carbon copy of what's up above. I converted the 8% into decimal form and said, all right, that's 0.08. And then multiply by 200, you get 16. So the original amount of 200 minus 16 would give you 184. The other way of doing it, if you want to do it all in one shot, the 100% in this last bullet point, that represents the original amount, minus 8%. So 100 minus 8 is 92. So what you would end up with after the 8% decrease is 92% of what you started with. So if you figure out what 92% of 200 is, that will give you the right thing. It'll just do it all in one step rather than having 100% minus 8%. It's just 0.92 times the 200. That'll also give you the 184. And again, that alternate way, that might not be for everybody. It is maybe a little bit less straightforward to look at, but if that makes sense to you, it is shorter. And there's nothing wrong with doing it that way. So either way will work, right? Whichever one is more comfortable, I guess. And if they're both comfortable, then probably going to do the faster one, right? All right, so some examples of increases and decreases. And I think there's one where there's both. So we've got a construction worker making $36,750 a year, gets a 2% raise. So what's the construction worker's new salary? All right, well, I guess if we think of the $36,750 as being the old salary, so I guess that's what I'm going to call it when I write this out. So I'm just going to think of this as old salary. And I'm going to say that the new salary would be equal to the old salary and then plus the 2% raise. But the 2% raise would be 2% of the old salary. So 2% of the old salary. All right. So then we know what the old salary is. It's $36,750. So I can put that in there. And then plus And here I'm going to convert the 2% to a decimal. So I'm going to say 0.02 times old salary, which is 36,750. And 0.02 times 36,750, since following the order of operations, you would do the multiplication here before you added. So we'd have 36,750 plus what we get for that product, which is 735. And then if you add those together, it's going to be 37,485. And as far as the units go, I think in the homework they tell you not to put them in. So I think they say don't write in the dollar sign. And then with percents, they usually say don't write in the percent symbol. It looks weird for me to write a final answer like that. So I tend to leave the units like dollar signs and things off until the final answer and then stick them back in. But I think when you input the answers in Newton, I think they want you to leave the dollar signs off. They tell you in every single problem, I think, but I'm pretty sure that's the way it works. And then the other way of doing this, so I guess I'll do this in a different color, just so it'll stick out. So the other way of doing it would be like the short way. If you said that the new salary, since there's a 2% increase, or the 2% raise, you could say, well, then this will be 1.02 times old salary. The old salary is the 36,750, so we'd have 1.02 times 36,750, and you will get the same thing. You'll get the 37,485. So you could do it that way too, right? If you would view 2% raise as, oh, I just take the old salary and multiply it by 1.02, yep, you'll get to the same place. So either way will work. All right, next. All right, this is actual numbers. They're like 2 days old as of the time when I'm making this video, so they should be fairly accurate. All right, so at Lawley Hyundai in Sierra Vista, a 2020 Accent has been marked down from 17,555 to 14,749. So what's the percent change? All right, so there's probably going to be one question about percent change on the homework for this section. The reason I wanted to stick one of these in here because percent change is actually easier than the other stuff. But percent change is an absolute quantity, so you don't worry about increase or decrease. So what you end up with, I guess in a general sense, the percent change is the absolute change divided by the original price. And here, the way that they're written with the 17,555 first, I think if you were going to find the absolute value of the difference between those, you would probably subtract in the order where you would get a positive number anyway, right? I think most people would write it as the absolute value of 17,555 minus 14,749. So that's what I'll do. I think it would be weird to write it in the opposite order for no apparent reason, even though you would actually get the same thing. So the numerator should actually be an absolute value. So it would be the absolute value of 17,555 minus 14,749. And then divided by the original price, which is the 17,555, right? Because we start there and then it gets marked down. So that means the 17,555 is the original price because that's the starting point for the reduction. So the thing that's in the numerator, I mean, if you subtract here, you're going to get a positive number anyway. So you get the absolute value of 2806. So then the absolute value symbol looks kind of redundant since you're taking the absolute value of a positive number, right? So then you kind of end up where you started with. But I'll leave it in there because if these were written in the other way, so let's say if I'd phrased it differently and I said it had been marked down to 14,749 from 17,555. Then maybe you write it in the opposite order, but if you're looking for the percent change, then that is just, it's an absolute concept, so you got to take the absolute value of the numerator. So you'd still end up with a 2806. Since if you reverse the order of subtraction, the absolute value of negative 2806 is going to be positive 2806. So well, you'd get to the same place either way. You'd end up with 2806 over 17,555, which is 0.1598 roughly. And actually, I can do this better. That shouldn't be a straight up equals. I said I wanted you to erase there. Right, I'm rounding, so I'll do the approximate equal there. But then 0.1598, if you convert that into percent form, is 15.98%. But then to the nearest tenth, we'd have to round up because we got an 8 in the hundredths place. So we'd get 16.0. Okay. So the biggest thing here, I guess, is just that you have to have the absolute value in the numerator. So if you happen to have one where it's the smaller value minus the larger value, just remember to take the absolute value then, I suppose. I think other than that, the percent change isn't too bad, but that was the thing I wanted to point out. All right. Number 7 is one where we're going to solve for the original price, where we know what the reduced price is, and we know what the percent reduction is. So, well, how would the 598 have come about? Well, this is a reduction, it's a decrease. So what would have happened is we would have, in order to get the new price, which is the 598, and I'll sub that in the next step, it would be the old price, or the original price, minus 18% of old price. Right? That's what the 18% reduction would be. You'd start with the old price, the original price, and you'd subtract whatever 18% of it is, and that's how you get the new one. So the new price, we know what that is. It's $5.98, right? Because that's the price after the reduction. Okay, $5.98 over there. Old price, we don't know, right? That's the thing we're trying to solve for. So I'm just going to call that X for now. Using any variable placeholder would be fine. If you want to call it X, if you want to call it A, if you want to call it P for price, that works too. I'm just kind of picking the most generic thing that I can here, I guess. And then minus 18% of old price. Well, we don't know what old price is, but we said that's X. So if I convert the 18% into decimal form so I can do the algebra, so that's going to be 0.18, and then that's just multiplied by X. But this thing that's over here on the right, I'm going to rewrite this slightly, and this step here you may not actually need, but we have 1x minus 0.18x. So I'm going to factor the x out and say that's 1 minus 0.18, that quantity times x. And 1 minus 0.18 is 0.82. So we'd have that 598 is equal to 0.82 times x. But then that means that if we divide both sides by 0.82 to get x by itself, so we'll have 598 over 0.82 equals 0.82x over 0.82. Then what we're going to get is, well, we're going to get an x on the right, and then on the left, what you get, let's see, at least to 2 places, it's 729.27. So 729.27, which seems like that would be a reasonable point to round off since this is money, right? At least 2 places, right? It would be weird to round to the nearest dime. It would make more sense to round to the nearest cent, right? But it did say give the final answer to the nearest dollar, okay? So for the nearest dollar for that looks like it's 7.29. right? Got a 2 after the decimal point, so you're going to round down. So 729 roughly is X. And we round that off. So that's the original price, or the old price, is 729. And I guess with these you can always check them if you want, right? Like if you put that in, like 0.82 times 729, it ought to be pretty close to 598. It won't be exact because we round to the nearest dollar, but it ought to be pretty close. Okay, next is number 8. Okay, number 8. Let's see, this one's got a couple of steps. So this is the one that's got both. It's got a decrease and an increase because we have that the house was purchased for $161,000 2 years ago. And then during the first year, the value of the house went down, right? Depreciated by 4%. But then in the second year, it appreciated, so the value went up. But that 5% is based on whatever the value of the house is at the end of year 1, right? So it's like you have to kind of view year 1 and year 2 as separate increments. So it's like year 1, you have some starting point, goes down 4%. And then that end point for year 1 is the starting point for year 2, and you'd apply that 5% increase to that. So that's basically what we're going to do. All right, so that's why we've got the whole page for this one, so I can write nice and big. And there is a lot to kind of diagram here. So for year 1, that's where we have the 4% depreciation. So we can kind of do what we were doing before. Depreciation is a decrease, so it's going to be a 4% decrease, right? So that's what this is. So a 4% decrease in value. All right. So then what we can do for year 1 is then the new price, which would be the price at the end of year 1, would be equal to the old price minus 4% of the old price, right? 4% decrease, subtract off 4% whatever the old price is. So, okay, the old price is your starting price here. So, right, like it's your starting point at the beginning of year 1, we're at 161,000. So we'd have 161,000 minus 0.04 times 161,000. So 0.04 times 161,000 is 6440. So this ends up being 161,000 minus 6440. And so then it's 154,560. All right. So that's where we end up end of year 1, right? So right there, this is the value at the end of year 1, which would be the same point in time as the beginning of year 2. So beginning of year 2, right? When one year ends, the next one begins. So that's going to be our old price for year 2. So now for year 2, just to have a little extra production value, I guess we can change colors and to make it easier to see where these are. So year 2, it's a 5% appreciation. So that's going to be a 5% increase in value. So here, the new price is going to be the old price plus 5% of the old price, right? It's an increase, so it's going to be a plus. So plus 5% of old price. Okay, so then we just have to use the old price, in this case, is what it would be at the beginning of the year, right? So in a way you can view these, and I'll do this with a different color. So the new price So new basically means end of year price, and old is the beginning of year price. I didn't write it that way because if I wrote end of year and beginning of year a lot, that made actually the line where I'm pointing at it with arrows extremely wide. And I thought, I don't know if I can write all this on one page. But that's what they are, right? So if you think of old as beginning of year and new as end of year, that's right. That's what's going on. All right, so we go back to Brown. And let's see. So now our old price is the 154,560, right? Because that's at the beginning of year two. That's what the old price is. Or I guess that's what the price is at the beginning of year two. So 154,560. And then plus, converting the 5% to decimal form, we'd have 0.05 times 154,560. And 0.05 times 154,560 is 7728. So you have 154,560 plus 7728. And what that ends up being is, I've got enough space to write it underneath, 162,288. So that's it at the end of year two. So that's at the end of year two, which would be current value. Since it said the house was purchased 2 years ago. So if we start 2 years ago and then go forward 2 years, we'd be at now, right? So that is the current value. And that one, I think if this one makes sense, the other ones are all going to make sense because the other ones were just one thing or the other. It was either a decrease or an increase, and this one had both. I should point out, and I need another color for this one, you can do this one in one very compressed, compact format too. Or you could do the whole thing like this. If you start off with the 161,000, and then for the decrease of 4%, you'd multiply by 0.96, and then for the increase of 5%, you multiply by 1.05. So there's the 4% decrease, and then here is the 5% increase. If you multiply this out, it is 162,288, and you'll get the exact same thing. So this is sort of using that compressed version for just like an individual decrease or increase, and then just doing it twice. Because then once you multiply by 0.96, then whatever that number is, you just multiply by 1.05 to get that 5% increase or 5% appreciation in there. So since it's multiplication, you can just do them just boom, 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 right? Just in sequence, one after another. And it will work. So I guess if that makes sense to you, that one that's in maroon, that's okay. There's nothing wrong with doing it that way. Or if you'd rather have it itemized, and there's nothing wrong with having things itemized. And in fact, some of the other stuff that we're going to do in this unit that looks more like accounting, it helps if you naturally do kind of itemize stuff. Because then when you have everything laid out, the accounting type things with loans and interest and that kind of stuff, that does tend to feel easier when it's all laid out. So there's nothing wrong with itemizing here too, but if it makes sense to do it real quick, like that maroon way, you can do it that way too. That's perfectly fine.